Greetings to all my tech heads out there in the KevTechify nation, and if you're new here, welcome. In this episode, we're going to look at cryptography. We'll be discussing creating ciphertext, transposition ciphers, substitution ciphers, a more complex substitution cipher, and then finally, one-time pad ciphers. This episode is part of my series on network security for the Cisco Certified Network Associate, or CCNA for short. I'm Kevin here at KevTechify. Let's get this adventure started. The history of cryptography starts in diplomatic circles thousands of years ago. Messengers from a king's court took encrypted messages to other courts. Occasionally, other courts not involved in the communication attempted to steal those messages sent to a kingdom where they were basically considered the adversary. Not long after, military commanders started using encryption to secure messages. Here we have the Enigma machine. This is the Enigma machine right here. Nice photograph of it. And this was an electrical mechanical encryption device that was developed and used by the Nazi Germany during World War II. The device depended upon the distribution of pre-shared keys that were used to encrypt and decrypt messages. In transposition ciphers, no letters are replaced. They are simply rearranged. Here's an example of this type of transposition cipher. Take the term cryptography is fun. So we take that term, and what we do is we just transpose it, take the first letter, put it last, and continue on that way. This would be the encrypted version of it. Not very secure, but it is a way to encrypt your messages. Another example here of the transposition cipher is known the rail fence cipher. Now, in this transposition cipher, the words are spelled out as if they're on a rail fence. Now, we have three different rails. So we have one rail here, a second rail, and a third rail. These are the rails going across here. What we do is we spell it out going down, up and down on the rails. So here, our message is going to be flank, east, attack at dawn. So a military message here. And what we do is we start writing out on the first rail, we put our F. Second rail, we now put an L. Third rail, we go to the A. Now we start going back up through the rails. And this only has 3 rails. You could put 7 or 8 rails in there. And as you can see, flank east is right here. Attack. So we got flank right here. East. Attack. At dawn. Going up and down our transposition cipher. Now, how you would write this out is you go across the top rail and you write down those letters. You'd write down our message F, K, T, A, T, N. The second line here would be L, N, E, S, A, T, C, A, D, W. And then the third line, or the bottom rail, would be A, T, K, A. The person would get these messages and they would have to know that there's 3 rails. You can tell that there's 3 lines, and then they would have to write that message out going across there using this transposition cipher. Substitution ciphers substitute one letter for another letter. In their simplest form, substitution ciphers retain the letter frequency of the original message. Meaning, if you have a 4-letter word, the encrypted message is going to have a 4-letter word. Here in this example, you can look at this. This is what you want. So this is what you want here. So you want an A. Down here is what you write. So if you want an A, what you do is you write a D. Now, basically all we're doing is shifting it over. You, instead of having the alphabet down here, you could also mix all of these letters up, make it a little bit more difficult to figure out. The Vigenere Cipher is based on the Caesar cipher. except that it encrypts text by using different polyalphabetic key shift for every plain text letter. Now, the different key shift is identified using a shared key between the sender and the user. The plain text message can be encrypted and decrypted using a Vigenere Cipher table. Here we can see we have a Vigenere Cipher table. And now I'm going to walk you through an example on how to use this. You can see that we have two sides to this. For me, seeing as I don't use this Vigenere Cipher a lot, what I do is on one side, I write down that this is my plain text here. That way I know this is my plain text. Make sure I get it right. On the top then, I write down this is my secret. What you have to have is a secret key in order to encrypt and decrypt this information. This key is shared between the sender and the receiver so that they can both encrypt and decrypt that information. Here, what we're going to do is we're going to use the plain text term cryptography is fun. So over here in the upper right, cryptography is the fun. And then for our secret key, we're actually going to use secret key. But as you can see, secret key is not long enough to cover the entire cryptography is fun. So what you do with the key here is you just simply start repeating it. So we start going secret. And then KE, we don't need the Y because that would be more than what we need. We start off looking at the first column. On the first column here, we have a C for the plain text. And for the secret key, we have an S. Where these two intersect, so we're looking at this column here, and we're looking at this column here. So that's the top of my column, that's the bottom of my column, to make sure I can highlight it right across there. And we come up with the letter U. And so with the plain text of C and the first letter of our secret key of S, we come up with the cipher of U. As you can see, that's right there. Now, we'll go through and we'll do a couple more here. R, down here. So that's this row right here. Secret key of E is right here. So that comes down to this column. Right here is where they circle, and you can see that this is a V. That's what we have right here. As you look here, you can see that the alphabet is shifted in here. In this table, we can see that this first column starts off with ABC going across here, but then the next one starts off with the letter here. So we start off with BCDE, CDE, and as you can see, we work through it that way. That's how we build that table. So if you look on the diagonal, we have all of the same letter on our diagonals. Working through here, we'll do two more. So we have a Y, which is way down here. That's that row. Going to a C. It gives us an A, and let's do one more. Clear text of P. Going to a key of an R. That would bring us right down here. That gives us a G. And then we slowly work through there. The other thing to notice is there's no space in the plain text. So up here in our plain text, there is no space in between our words because there is no space built into our table. Gilbert Burnham was an AT&T Bell Lab engineer who in 1917 invented, and then of course later patented, the stream cipher. He also co-invented the one-time cipher pad. Gilbert Burnham proposed a Teletype Cipher in which a prepared key consisting of arbitrary long, non-repeatable sequence of numbers was kept on a paper tape. And that's what we have here, is that Teletype Cipher. It was then combined character by character with the plain text message to produce that cipher text. To decipher that cipher text, the same paper type key was again combined character by character, producing the plain text. Each tape was only used once, hence the name one-time pad. Several difficulties are inherent using this one-time pad in the actual real world. It was my pleasure to provide you with this wonderful episode on cryptography. If you like this episode and you got value out of it, and of course, depending upon what platform you're using, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All of my socials and contact information are on my website, KevTechify.com. I also show you how to get all these episodes in video and podcast form. In the upper right is my playlist for my series on network security for the CCNA. In the bottom right is one of my favorite videos that I picked out just for you. Thank you so much for watching this episode of my series on network security for the CCNA. Once again, I'm Kevin. This here is KevTechify. I'll see you next time for another great adventure.